You've got your PLC program running perfectly until the field happens. A sensor dies, wiring changes, a spare normally open switch replaces a normally closed one. Suddenly you're hunting through your entire program, fixing addresses and possibly even logic. I/O mapping is widely considered to be a best practice for many use cases in PLC programming because it helps avoid all of this. If you're maintaining machines over time, supporting equipment in the field, or building reusable or modular systems, you'll definitely want to look into its benefits for your applications. It can be used in any PLC platform, but Do More Designer has a couple of features that really facilitate its implementation. Let's take a look at what I/O mapping is and why it's a natural fit for Do More programming. Instead of reading and manipulating I/O points directly throughout the program, you map each input point to an internal tag. The program reads and manipulates the internal tags during the scan and then maps the internal tags out to output points. Do More Designer features built-in top-of-scan and bottom-of-scan tasks that are perfect for mapping. In the top-of-scan task, copy all your analog inputs to internal input tags of an appropriate data type using a move or copy box. If there's any scaling or manipulation that needs to be done aside from what is set up in the hardware setup, you can use a math box here for that purpose. Say your thermocouple input card is set up for Fahrenheit, but the end user wants to be able to switch between Fahrenheit and Celsius. This is a great place to do that scaling. For discrete inputs, rather than a copy function, I recommend using an out instruction with a normally open or normally closed contact depending on the input. It keeps maximum flexibility. After the logic has taken all of these mapped inputs and done its work to the internal output tags, use the bottom of scan task to move, copy, and out these internal tags to the physical output points. So why go to all this trouble? Flexibility with hardware changes may be the most important long-term benefit. If a module or channel fails, you can remap to a spare in one place without searching, replacing everywhere in the logic. And say an input normally open limit switch goes bad, and the field tech has to replace it with the only switch he has, which is a normally closed instead. Just change this one contact and you're back in business. Easier maintenance and troubleshooting. All physical I/O is centralized in one task. You can quickly see statuses, forces, simulate inputs, and verify outputs without hunting through the entire program. Scalability, modularity, and reusability. The advantages of I/O mapping really come into play for someone like an OEM programmer or a machine builder. Say you're dealing with a line of machines in which different models do essentially the same thing, but each may have different I/O configurations. Drop the same code in both and make a few tweaks to the I/O map. Or reuse sections of code from one application in another without the danger of I/O not matching. If you have any questions, we offer many avenues to our free technical support. Click the link in the description below to explore those. Make a phone call, or skip all that and post your question in the comments. Make your Do More code more flexible, more adaptable, and more future-proof with I/O mapping.